We're going to be learning about writing quadratic functions in three different forms. Our three different forms are standard, vertex, and root. So root is the same thing as our x-intercepts. So let's take a look at number 1. Here's my function right here. F of x equals negative 2x squared minus 12x minus 10. This is clearly right now in standard form where we have an a, b, and a c. From our standard form, we can easily find the vertex using this right here. So for our vertex, our x value is going to be negative b over 2a. So what I'm going to do is just plug in my b and my a into this formula, and that's going to tell me the x value of my vertex. So I have a negative. When I plug in b, this is a negative 12. So I'm actually going to have two negatives up here. 2 times my a value is negative 2. And when I simplify this, a negative times a negative, this turns into a positive 12. 2 times negative 2 gives me negative 4. 12 divided by negative 4 gives me a negative 3. So the x value for my vertex is going to be negative 3. Now to find my y value, all I need to do now is plug in this negative 3 back into my equation. So I'm going to find f of negative 3. And so I'm going to replace all my x's here with negative 3. So this is negative 2. Instead of an x, I'm plugging in negative 3. Minus 12 times negative 3 minus 10. So using our order of operations, first we're going to do exponent, so negative 3 squared. Negative 3 times negative 3 gives me a positive 9. Right? I can multiply negative 12 times negative 3, which gives me a positive 36. Negative 2 times 9 is negative 18. And when I put all these together, negative 18 plus 36 gives me 18 minus 10 gives me 8. So my vertex here is negative 3, 8. Now to go from our equation to our roots, we're really just finding the x-intercepts. So we're trying to figure out when y is equal to 0. So what I first need to do to find my roots is I'm trying to factor this out as much as possible. So to factor this out, I'm looking at this equation right here. Is there a number we can divide out of all three of these terms? Yeah, there is. You can take out a negative 2. So if I take a negative 2 out of everything, this leaves me with x squared. Negative 12 divided by negative 2 gives me a positive 6x. And then negative 10 divided by negative 2 gives me a positive 5. And to solve for my roots, I'm just setting this all equal to 0 because this is when y equals 0. Now from here, this is what I'm factoring, so I'm using my x. So what two numbers multiply to give me 5, add to give me 6, positive 1 and positive 5. So I can rewrite this as x plus 1, x plus 5 equals 0. And now I'm just setting both of these equal to 0. So x plus 1 equals 0, x plus 5 equals 0. Subtract 1 from both sides, I get x is equal to negative 1. Subtract 5 from both sides, I get x is equal to negative 5. And these are my two roots right here, which I can just rewrite in a point form. So my x is negative 1, my y is 0. X is negative 5, my y is 0. So here are my two roots. Now to find my axis of symmetry, this is actually something from our vertex. So once we know what our vertex is, our axis of symmetry is just the x value. So whatever your x value is, your axis of symmetry is going to go straight through your vertex because that's the middle of your graph. So x is equal to negative 3. Finally, our y-intercept is also very easy to find because it's just the c value of your standard form. So whatever c is, so in this case negative 10, your y value is just 0, negative 10. X is 0, y is negative 10. Because for your y-intercept, this is when x is equal to 0. For your roots, this is when y is equal to 0. So from all this, now we can actually graph the function and rewrite it in the three different forms. So let's use the information we found to graph it. We can graph the vertex, which is negative 3, 8. So this is the vertex. The roots are at negative 1, 0, and negative 5, 0. So right here and right here. So I already know I can connect these. It's going to be in the shape of a parabola. We also have, we know that the y-intercept is 0, negative 10. So this one goes down here. And because it's symmetric, since from here to here this one's going down to 10, on this side it's also going to be going down to 10. Because we know it's symmetric across the y-axis. Or across the, it's symmetric across the line, in this case x is equal to negative 3. That's my axis of symmetry. Okay, so let's write our three forms. Our standard form is the same thing we started off with, so negative 2x squared minus 12x minus 10. Our vertex form, so for our vertex form we have f of x equals a, which is the same value as before, so negative 2. And now we have x minus h. So if h is the value of our vertex, so this is h and this is k. H and k. So we have x minus h, so minus negative 3, which actually makes us a plus 3 squared. And then plus k, and our k value is 8, so plus 8. That is our formula for our vertex form. Again, here's our h, here's our k, and that's what we're plugging in here. For our root form, we've actually already found it. It's right here. It's just factored out. So this is negative 2. We have an x plus 1, x plus 5. This right here is our root form. Okay, so let's look at some other problems. So we're going to be given some information here, and from this information we need to be able to find an equation. So we're writing an equation for each of these situations. Let's start off with number 1. So write the equation of a quadratic function with roots of negative 2, 0 and 3, 0, and a y-intercept of negative 12. Because they're giving us our roots, we know we're going to be using root form, which is f of x is equal to a x minus r1, x minus r2. So we have our two roots here. This is r1, r2. So we can just plug those into our formula. So f of x equals a x minus negative 2 is the same thing as plus 2, and this is x minus 3. So this is what I'm starting off with. The other piece of information we're given is that we have a y-intercept of negative 12. If you have a y-intercept of negative 12, this means that your x value is equal to 0. So really, they're giving us a point here, 0, comma, negative 12. And this is your x and your y value. So we have both x and y. So really all we need to do now is we don't know what our a is. We're going to solve for our a by plugging in our x and our y. So since our y is negative 12, we're going to plug in negative 12 right here. Our x is 0, so we're going to plug in 0. And we're solving for a. So we have negative 12 is equal to a times 0 plus 2, which is 2. 0 minus 3 is negative 3. We can multiply together 2 times negative 3, which gives us negative 6. And I'm just going to put that before my a because that's how we're used to seeing it written. To get a by itself, we're going to divide by negative 6. And we get that a is equal to negative 12 divided by negative 6. Is positive 2, and so I've solved for my a. Now all I need to do is go back and plug it into this equation. So f of x is equal to, a is 2, x plus 2, x minus 3, and this is the equation for the situation. Okay, let's look at number 2 now. So write the equation of a quadratic function with f of negative 1 equals negative 7 and a maximum value at f of 2 equals negative 1. So a maximum looks like this. So in this case, since it's the maximum, this is actually also our vertex. So if they give you the maximum or the minimum, it's telling you the vertex. So our vertex here is, this is my x value 2, this is my y value negative 1. And so for our vertex, we know in vertex form, vertex is h comma k, so I'm going to label this, this is my h, this is my k. And I'm going to be plugging these values into my function, so f of x equals a x minus h squared plus k. So this is what I'm starting off with. I'm going to plug my h and my k into this function. So x minus 2 squared minus 1. And now we're going to use our other piece of information, which is this one. So they gave us another point. So much like our last one, we have an x and a y here. Negative 1, negative 7. Here's my x and here's my y. I'm going to plug these numbers in so that I can solve for a. So my y is negative 7. we don't know what a is. I'm going to plug in -1 in for x. So I'm going to solve. -1 minus 3 is -3. Again, PEMDAS, so I'm going to first do the -3 squared. -3 times -3 gives me +9. I'm going to put that in front of my a. And now I'm solving for a, so I'm going to add 1 to both sides. I got -6 is equal to 9a. Divide by 9, and I get that a is equal to -6 over 9, which if I divide both by 3, I get -2 over 3. So again, here's my a value. Now all I need to do is go back to this function and plug it in. So I have f of x equals -2/3 x minus 2 squared minus 1, and that is my equation for this problem. Okay, one more. So for number 3, we're going to write the equation of a quadratic function with a minimum point at f of 3 equals -5 and this other number. So again, minimum or maximum, this is our vertex. So our vertex is 3, -5. That's my h and my k. So again, I'm going to plug it into my vertex form. I have x minus h, which is 3 squared, plus k, so this is -5. And now we have our other point, so we have 1, 2, which are my x and my y, and what I'm going to plug in to solve for a. So y is 2, so that goes over here. X is 1, and again, following order of operations, I'm going to simplify and solve. So 1 minus 3 is -2. -2 squared gives me 4, so 4a minus 5 is equal to 2. And now we're just getting a by itself. So plus 5 to both sides. 7 equals 4a. Divide both sides by 4. We have that a is equal to 7/4. And again, we're just going to go back to our original equation, plug in 7/4, x minus 3 squared minus 5, and this is my final answer. So we're not going to do number 4. So now it's time to get started on your assignment.